Okay, so if you're just tuning in, if you're watching the video, you maybe didn't experience or go through the activity we did. So I want to summarize real quick a couple of things. So we learned an activity that when you have an exponent of 1/2, that means the same thing as the square root. So if I have 3 to the 1/2, I can think of that as the square root of 3. If I had 2 to the 1/4, that's the same thing as the 4th root of 2. So now what we're going to do in section 6.6 is take that and then do a little bit of expanding. But this very first section, see, we've got a few problems. I didn't write much for instructions. I just said rewrite. And what I mean by that is rewrite it in the opposite form. So one form is when we have an exponent, that's a fraction. Fractions are oftentimes referred to as rational, so a rational exponent. The other form is when we use a root or a radical. We can have rational exponent form, or we can have radical form. So we're going to kind of switch back and forth between those in this first section. So if number 1 says a to the 1/7, and I want to write that in the other form, I'm going to have to write it in radical form. What kind of root will it be? Yeah, it'll be the 7th root. All right. Done. But you may notice in the next one, the second one, something a little bit unique. It says b to the 2/3. I have an exponent on there, or a numerator. So yeah, the numerator rather is what I meant to say. There's a numerator different than 1. And so I have to deal with that. If we think about our properties of exponents that we've talked about previously, you could rewrite this and separate the exponents. I can think of it as b to the 1/3 to the power of 2. We've learned before, if we have a power raised to a power, we multiply them together. So if you took 1/3 times 2, that would be the 2/3. You don't have to bother rewriting it in this step every time, but it might be helpful. And so now we see that we can write this, if it's b to the 1/3, that would be the 3rd root of b. But then, because the numerator was 2, we have to square it. And there is an alternative way to do that square. Instead of putting the square outside, you can put the square directly on the b. That would be fine too. So you can think of it as the cube root of b squared instead of the cube root of b squared. And there might be times where one makes sense, one makes more sense than the other. But you'll see in a little bit, we'll have a problem where we're trying to evaluate, and we'll kind of use that first one, might make more sense. So sometimes that first one's better, but either one's fine. So then number 3 and 4, we're going to go the opposite direction. So number 3 is written as a radical, and so I want to write it as a rational exponent. C to the power of what? The root, it's a 5th root, the index is 5, so 5 will be our denominator. And so the 3 becomes the numerator. So it equals c to the 3/5. So then when I look at the next problem, the -2, be careful. We need to put that -2 in parentheses. The parentheses there shows that they're grouped together. The negative goes with the 2. And I did take the cube root of the whole thing. So those parentheses become important. It is a 3rd root, so that index of 3 becomes my denominator, and it was to the 4th power, so the 4 goes to the numerator. You'll notice on numbers 3 and 4, on number 3, the exponent of 3 was directly on the c, but on number 4, that exponent is outside of the whole power. It didn't matter. Either way, it went to the numerator. So that's how we can rewrite, just kind of understanding how they connect. But now let's take a look at some especially rational exponents and do some work with them. So we're going to first do some evaluating. And evaluate means find the value of. So I'm expecting a number for an answer. And on number 5, I gave you a negative exponent. We need to remember our rules for exponents, and they apply to all of the problems we'll be doing today. And one of those was what to do with a negative exponent. Do you remember? If we have a negative exponent, it's going to happen. We will have a square root, but the fact that there's a negative there means we move it to the denominator. So we're going to have like a fraction. And when you move it to the denominator, it becomes positive. So I do have 49 to the positive 1/2, but it's in the denominator. So the numerator would just be a 1. So let's go ahead and do 49 to the 1/2. But just understand it's 1 over that. So an exponent of 1/2 does mean square root. Square root of 49 is 7. So 1/7. And I didn't bother writing it as a square root because I think with 1/2 we can hopefully understand that 1/2 means a square root. But on number 6, we've got some bigger numbers. So on number 6, it might be worthwhile to rewrite it. You might actually want to think of this as the 8th root of 256. And so my question here, does it make more sense to put the cube directly on the 256 or on the entire radical? And I would argue that it makes a lot more sense to put it outside. The reason being, I don't want to take 256 to the 3rd power. That would be really large. I'd rather do the 8th root of 256 and then worry about the cube later. So that's what I would do. So 8th root, that's still a big, very big power. And you might not be real familiar with 256. But I will tell you it's a power of 2. If we think about 2s, 2 to the 1st power is just 2. 2 to the 2nd power would be 4. 2 to the 3rd is 8. And 16, and then 32, 64, 128, 256. Okay, that's where I wanted to go. That was 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 4th, 5th, 6th, 7th, and 8th. Oh, 2 to the 8th is in fact 256. So therefore, the 8th root of 256 is 2. And then I have to take it still to the power of 3. So 2 to the 3rd, that's 8. Knowing different powers can be very helpful. You're probably familiar with squares. You might not be as familiar with cubes or 4th powers or 5th powers, etc. Right now on the board in the class in red over there, I have several powers. I have cubes up there and a few powers of 4ths. Those are worth being familiar with. And we'll probably see those in class periodically. But now let's go into some simplifying where we definitely have to understand on number 7, properties of exponents. Before I do number 7, think about a problem like this. You're probably a little more comfortable with something like this. X to the 3rd times x to the 4th. What would that equal? X to the 7th. So what did we do? We added our exponents together. Same idea here on question number 7. I have the same base number, so I'm going to keep the p, but now I have to add my exponents. So take 1/4 plus 9/4. They already have a common denominator, so it becomes not fifths, 10/4. And can I simplify that further? Yes, because 10/4 simplifies to 5/2. And there's our answer. the first few problems in our notes, we were writing in the opposite form. This is not asking you to write it in the other form. It's only asking you to simplify. So I don't have to write it as a square root or simplify a square root. This is what I wanted. A good rule of thumb is to make sure that your answer is in the same form that the problem was written in. Some of the problems will be written in radical form, like questions 9 and 10. Some of them are in exponent form, like 7 and 8. So try to match your answer to the same form of the problem unless it asks you to rewrite it. Okay, number 8. Here's a negative exponent again. So just like we did a little bit ago, I would move that to the denominator. And here's the problem where initially it's probably going to be helpful for me to think of this in the other form because we did this type of problem in the last section. And so you're probably more familiar with that section. After you learn, after you see it switched around, I don't think it's worth writing the other form. I think it's actually easier in this form with exponents that are fractions, but until you become a little bit more experienced with them, it's probably going to be beneficial to rewrite. So let's do that and see what it would look like. It would be the 5th root of r to the 4th. Yesterday, we talked about fractions and the fact that we cannot have radicals in our denominator. We have to rationalize them. And so that's what I have to do here. I would have to multiply something in. Notice my index is 5. It's a 5th root. So I would want 5 of something. Right now I have 4 r's. So I'm almost there. I don't quite have 5. So I have to multiply in the rest of whatever I needed. Well, if I have 4 r's, I need 1 more. So I'm just going to multiply in an r. You would have to do that to the top and to the bottom. And then we could finish the problem from there. But what I'm more interested in, rather than finishing that problem, is figuring out how could I have manipulated the problem I gave you in number 8 with the exponents instead of switching it to radical form. So think about what I'm multiplying in. I'm multiplying the 5th root of r. If I wrote that in the other form, that would be r to the 1/5. So I'm really multiplying in r to the 1/5. I have to do that to the top and to the bottom. I wonder how I could have predicted that without needing to rewrite it. My goal and hope is that you don't even have to do this up there. You can look at the problem and know what you need to bring in. And so if we look at what happens after I multiply it, that may help us understand why we did 1/5. If you focus on the denominator, r to the 4/5 times r to the 1/5, just like on the last problem, we added our exponents. That's what I would do here. 4/5 plus 1/5 makes 5/5, which is just 1. So we'll have just r in the bottom, which it doesn't have a radical or a fractional exponent anymore. So that's how I know that I need to get 1/5. I have to bring in something that I would add to the 4/5 to get me to an integer. It's not always going to be a 1. Sometimes it might be 2 or 3 or something. But to get from 4/5 to an integer, I needed to bring in 1 more 5th. And so if I multiply that to the numerator, 1 times r to the 1/5 is just r to the 1/5. There is nothing I can do with that. Here is my answer. R to the 1/5 over r. Normally, we don't like the same variable or the same base in the top and the bottom. But the fact that I cannot have a fractional exponent or a radical in the denominator supersedes that. So nothing more I can do to this problem. Okay, let's look at another fraction problem. Number 9 should look pretty similar to what we did yesterday. and we rationalize the denominator, but there's one important difference why I can't and I won't approach it the same way that I did in the last section, and that's that the top and the bottom have different indices, have a different index, a different type of root. The top is a fourth root, the bottom is a third root. They're not the same, so I won't be able to combine them together. So this is a problem where it makes more sense. It's going to be easier if I write it as an exponent that's a fraction. And first of all, I should write 32 as a power. So once again, if you're not familiar with your powers, you're going to need to probably get more and more familiar with those. But 32 is a power of 2. It is 2 to the 5th power. Oh. Okay. And I wanted to have the same base in the top and the bottom, and I see that's going to happen. That's another reason I knew I would be benefited by rewriting it. And now let's go write it in exponential, like as an exponent, fractional exponent. So it's 2 to the 5/4 in the numerator, 2 to the 1/3 in the denominator. Now to think about what to do here, let's think about a problem like this, something a little more basic that we've dealt with before. If I had x to the 5th over x to the 2nd, what did that simplify to? We would have x to the 3rd. Why? Well, we subtracted the exponents. 5 minus 2 gave us 3. That's what I'm going to have to do over here on number 9. I'm going to have the base number of 2. You keep that base number, but you subtract the exponents. The one on the top goes first. So I have 5/4 minus 1/3. Before you can add or subtract fractions, you have to have a common denominator. So now I'm going to rewrite those fractions, giving them a common denominator. Looks like I need to have a denominator of 12. So the first fraction had a denominator of 4, so I had to triple it and multiply by 3, so it becomes 15/12. Meanwhile, the second fraction had a denominator of 3, so I have to quadruple it or multiply by 4, so I get 4/12. And now I can go ahead and do 15/12 minus 4/12. 15 minus 4 is 11, so it's 11/12. That fraction cannot be simplified, but I made mention of the fact that we should give our answer in the same form that the problem was written in, unless it says otherwise. So it was originally in radical form, so I'm going to go change my answer back now to a radical form. So it's a 12th root of 2 and it's to the 11th. I don't care if you put the 11 on the 2 itself, or if you put it on the whole thing. Either way, it's perfectly fine. What I probably would not bother doing, because 11 is so large, is I probably wouldn't take 2 to the 11th power. I could do that. I could figure out what that number is. That's a big exponent, so I'm not going to bother with it. So I'm going to leave it like this. Okay, I got to kind of pick up the speed. Actually, I'm going to skip over number 10. I'd rather look at number 11. Here I have to multiply by the conjugate, just like we did yesterday. So you focus on the denominator, you just had to change the middle sign, and now you FOIL. When you multiply your y to the 1/2 times y to the 1/2, you add your exponents. 1/2 plus 1/2 is 1, so that just becomes a y. Plus 2 y to the 1/2 plus another 2y to the 1/2 plus a 4. Bell's about to ring, so I'm trying to kind of hurry. I would highly recommend making sure you do this assignment, or at least part of it, because, sorry, that should have been a y, not y to the squared. You should do this assignment because we're not really doing enough practice on it in class. Those will cancel in the bottom, so you get y minus 4, and there is your answer. Back up to number 10 real quick. 16 is really 2 to the 4th. Since I have an index of 3, I need 3 2's to pull one out, so I get to pull one out. I also get to pull out an x, but I have a 2 left and an x left. This is really a problem from like similar to a problem from a different section, so it's not really new, just a little bit of extra practice.